Today let's try to solve another Leetcode problem 543, diameter of binary tree. So we are given a root of binary tree and we need to return the length of the diameter of the tree. So we need to understand what is the meaning of the diameter of a binary tree. So it is the length of the longest path between any two nodes in a tree. Yeah. So if it is between any two nodes, for example, 2, 1, 3, but this is a path, but it's not the maximum. We need to return the maximum. Maximum is 5, 2, 1, 3 or 4, 2, 1, 3. Yeah. So yeah, according to the definition of the diameter of the binary tree is the length of the longest. Yeah. So the longest 2, 1, 3 is not the longest. So the longest is 5, 2, 1, 3. So we're gonna return a 3 as our diameter. But for the path, it can be 2, 1, 3 as well. But it's the definition of the path. But we need to return the diameter. So it's gonna be the maximum path between two leaves of the tree. So for example, 5 is a leaf of the tree and 5, 2, 1, 3 is another leaf. Or we can use 5, 2, and 4, but the length of the path is only 2. Yeah, so the diameter, the maximum should be 3, 5, 2, 1, and 3. So first, let's go to the whiteboard to understand the combinations of the binary tree, and then I will go to the code editor to finish the coding. So for example, if there's only one node, yeah, if we only have a node 1, so what will gonna happen? For the left side, it is a none, and for the right side, it is a none. So the result is just 1. Yeah, because from the left side, it is a 0, and the right side, it is also 0. Yeah, so the maximum of the left side plus the right side with my current result is still gonna be 0. Yeah, so for the first example. So for the second example, so the left side is 1, but the right side is 0. So the path from the left side plus the right side, it is 1. So this is the diameter. And for the third example, for the left side, it is 1. And for the right side, so the depth is also 1. So 1 plus 1, so the result is 2. Yeah, so according to these examples, we can write the function. So if there's no node from the left side or the right side, so we're gonna return a 0. So this 0 means the depth is just 0. But we would need to update the result by the left side plus the right side. So it means 0 plus 0. But for the recursive function, what we need to return? So we need to return the maximum depth for either side. So for example, for this 1, 2, and 3, what we need to return, finally, we're gonna return as 2. Why? Because in my function, I'm gonna, for this example, I'm gonna return a 2. Because if there's another node, for example, if it is connected, so for the left side, it's gonna be 1 plus 1, it's gonna be 2. And for the right side, if there's another one, so the depth gonna be 3. Yeah. Let me go to the code editor. I think it's gonna be much clearer when I code it up from here. Yeah, basically there are too many ways to write the recursive function. Yeah, so for me, I'm going to define a DFS function. So this is basically a post-order traversal. So inside the DFS, I'm gonna define a root as my node. So I'm gonna define a node. So I'm gonna call the DFS. Inside of the DFS, it's gonna be the root. Before that, I'm gonna define a global variable. The result gonna start as 0 because at least I will have one node, so the diameter should be 0. Yeah, after call the function, I'm gonna return this self.result. Now I need to write the main function for the DFS. So if there's no node, so I'm gonna return a 0 as my depth for the left side or the right side if there's no node. Now I'm gonna check the left and the right side. So this means I have a node. So it's gonna be the DFS not dot left and not DFS not dot right. Yeah, but for this function, what I need to return, I need to return the max L and R plus 1. So for example, I only have a 3 node. Yeah, like this example. It means that we only have 2, 4, and 5. So for this 3 node, I'm gonna first check the node. If not node, I'm gonna return 0. For 2, I have a left side and a right side, so I'm going to the L and R. So for this L and R, it's the left side and the right side. So for the L, for example, I'm gonna go to the node 4. So for this node 4, I'm still go to the recursive function for the DFS. If not node, I'm gonna return 0. So for this node 4, I have a node. So for L and R, gonna be the node dot left and right. So for this node dot left and right, it's gonna be 0. Yeah, but what I need to return is the maximum with L and R plus 1. This means for this 4, I'm gonna return a 1. Yeah, and for this 5, I'm gonna return a 1 as well. So I need to update my result. So my result is should be self.result should be the maximum of self.result with L plus R. So this is actually the diameter, the maximum path. Yeah, but the return for my function for this node 2, it's gonna be 2 because here the return is maximum of 1 and 1 plus 1, it's gonna be 2. And if I were to calculate the node 1, for example, this node 1, so for this 2, I've already returned a 2. So this 2 actually I've already plus the path connected from 1 to 2. So this is why I write it like this. So similarly for this node 3, I'm gonna return a 1. So this 1 means I've already plus the path connected to the root node 1. So this means for this 1, my self.result would be updated to with L plus R. So L should be 2 and R is 1. So it's gonna be 3. So this is why the result is 3. Now let me submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. And the time complexity is just a DFS post-order traversal, so it is ON. Now let's change something. Yeah, if we analyze like some other ways, maybe we only want to check this node. For this node, yeah, we only want to check the return. The return should be not 1. So if this node we're gonna return a 0, what about? If it is a return a 0, how we need to check the path? So the path should be 0 plus this 1 plus this 1 plus another 0. Yeah, so in that way, we're gonna change some function, so the return gonna be -1. And here, while we are checking the maximum of the result is going to be L plus R and plus this ends and this ends from 2 to 5. So we're gonna plus 2. Yeah, so this is another way. Maybe it is much clearer when what we are calculating. Yeah, we need to calculating from the left side and the right side also plus the 2 edges from 2 to 4 and 2 to 5. Now let me just submit it. Yeah, and yeah, just submit it to check if it works. As you can see, it should also, yeah, it also works. Yeah, this is why, because we changed here to -1. This -1 means if we are going to this node 4, if we only have a node 4, so for this 4, actually, what we're gonna return, we just return the maximum of -1 and -1 plus 1. We're gonna return a 0 from here. Yeah, but while we are updating the result, it should be L plus R plus this 2. So for this node 4, it's gonna be -1 plus -1 plus 2. So it's gonna still be 0. Yeah, so this is another way of writing the DFS. Thank you for